So I want to review the linear regression. So I've got some points here. How do we draw a scatter plot? 63.1, right? Yeah, so go ahead, draw your scatter plot. You should be right on the paper there. There's your 3.6. 62 is 3.8. 65, 4.1, right? So line of 6. We go to our calculator. I got some junk in mine. If you have stuff in yours, just clear it out. I'm just going to do this here. Okay, so we put it in stat edit, remember? And L1, put in your x values. L2, put in the y values. Takes me a little longer on this thing. Checking my numbers here. I think that's okay. Oh, I'm going to find out, right? So you put your numbers in, L1, L2. Line of best fits. Tell me what I do here. Stat. Out. Linear regression. I want to see if there's a line of fit. Number 4. And then y equals ax plus b. Here's a, here's b, right? So you substitute in the a, you substitute in the b. Approximately, y equals, I'm going to go to the nearest hundredth, 0.19x minus 7.9, let me go back and look. Minus, right? 7.96, right? And what does that mean? That means if you were to fit a line through here, right? Remember the spaghetti? You just kind of put this through here and hope that it's the best line of fit, or it is the best line of fit. We were probably not laid correctly at that. And then there was a way to say, gee, is this a good linear fit? Do you remember how you figure out if it's a good linear fit?
Oh,
Yeah, what do?
you go to catalog.
Catalog. So you look at your 0 button. You see the word catalog?
And then you
Second, that button, right?
yeah, and you do D.
I want the D. Now notice my output is on already. So the green, for my calculator, is green. I'm looking for D. And boy, I cannot see on this thing.
It's on X or it's negative.
This guy, right? The x2 minus 1. D. And I'm only doing that to position it. Right? I'm positioning because what command do I want?
You want diagnostic.
Diagnostic on. So I'm scrolling down. There's diagnostic on. And then you press enter. And is that good enough?
No,
Press enter again. You want to see that word done. That means it actually turned the diagnostics on. So now, when I do a stat and a calc and a linreg, I get more stuff. I get this R, which is the correlation coefficient. Is this a good one?
Yes.
What's the best one?
1.
Or negative one. Remember, this can be positive or negative. So the closer, like the absolute value of this is to 1. So that's pretty good. Now we kind of ignored R squared. R squared is the coefficient of determination. I believe that's what it's called. And it works very much the same way to tell us if we have a good fit. It's basically a percentage. It's a percentage saying 83% of the points are actually fitting this linear pattern. So that's pretty good, right? What would be best? 100%. So again, this is a number that we want to be 1. This one's always going to be positive because 100% is positive. So I can actually look at this number as well. So 0.83, is that good? It's not bad. It's not bad. You know, it's not 1, but it rarely is in real life, so that's not bad at all. The other thing we did with these was we played with them a little bit, where if I say, well, great, now that I know these, and I have a line, I can kind of make a guess. Like I've got a missing value of 64. So if I wanted to find that missing value, how would I do that? Or make an educated guess. Right? That's an x, right? I've got a function, I can just plug it in. So if you plug in 64.19 times 64 minus 7.96, what do you get? Somebody do that for me. 49.6, is that what you get? And I don't know, I'm letting you do it. The other way you could do that is kind of let the calculator build these tables for you. And let's review how to do that. There were some keystrokes involved. Remember that? So stat, calc, in red, number 4. Now if you're using L1, L2, great. If not, you have to do L1, comma, L2, comma. If you're using L1, L2, you can just hit the bars button. You press bars. Remember what you do? Move over one to Y bars, where you see function. Then you hit enter, and I want Y1. And it puts a Y1 here, which means when you hit Y equals, it's going to have the Y1, have your function in there. And you press enter. So it doesn't look much different, but now if I go to Y1 equals, it actually took that function that it created and put it there, which means under table, I've got a table of values. So table is the graph button, except look up, you see table, second table. And so when x is 0, you get this. When x is 1, you get that. Or when y is negative 7.4, that's x is 3. Now I want to know x is 64 because I want this missing value. You can absolutely scroll, no big deal. Or you go to table set, which is above the window button. So see table set? Press the second button on the window button to get there. And I just want to position myself closer. I'm going to look for where x is 63, or you could say 64. Remember what delta does? If you want to go by ones, just leave it 1. If you want to go by halves, you can put it in half. Go back in my table. So what do I want? 64? Yeah, 4.05, which makes me think that what you got here is not correct for this. What is it? 4.10-ish, right? This is rounded a lot, so it's not going to be the same. So you get a more exact answer when you go through the table. Now, who remembers doing this? Anybody? Nobody! Nobody remembers doing this? We never did this.
Oh, me in general.
We never did this? Look under your tests. There's one that says linear regression. We did so.
We did that.
We did so. Okay, wait, so what? We never did this.
We did this, but we all forgot.
Okay, that's different than we never did this. It's we did this and I forgot. They're like, we never did this. I did this right. Okay. I just got a little nervous. Did I
We
forget
said we
something?
did it
Look, x equals 59. So I look for x equals 59 in the table. That's going to be 3.12. X equals 64. We just did that one. Oh, my eyes are so marbled. 4.06. And I'm rounding to the nearest hundred. X equals 67. Let me scroll down and see when x is 67. Y is 4.62. Right, I'm using the table. You don't have to. You can use this. This was our estimate of the line based on that. Now you can also say, given a y value, what's the x value? So if it's given a y value of 2, I'm actually looking at this column. It looks like they get smaller up here. So if I'm looking for 2, y of 2, oh, here it is. That's pretty close to 2. It looks like x is 53. If you don't want to do it that way, you would have put a 2 here, and you have to solve this equation. So either way, right? Please tell me that I remember doing this. I may not remember all the steps, but I remember sort of doing this. If I have no memory, I'm a little concerned. There was a test and everything. Look in your test. You're going to see a whole thing here. You probably did great on it, too. I think a lot of people did well on it, which you should remember that. Okay, so linear regression. The line of best fit allows us to make predictions for data that's pretty much linear. However, data isn't always linear. What if it looks like some other curve, like, I don't know, what have we been working on? These things or these things? What if it looks like a parabola? What if it looks like a quadratic? So sometimes data forms a shape that is quadratic, and you can fit it. Remember our standard form, ax squared plus bx plus c? It would fit in here. So fitting to a quadratic curve, guess what it's called? Quadratic regression. Linear regression fits a line. Quadratic regression fits a parabola, quadratic. So here's the good news. Who likes good news? Nobody. Thank you, 3 people. The steps are almost exactly the same. Almost exactly the same. You plot the data in L1 and L2, just like you do with the linear regression. However, when you have your data in there, and I'm going to keep the data that we have, that I already have in my L1, L2, I'm going to do my stat and my calc. I want a quadratic regression. What do you think I should press? Number 5, quadrate. So I go down to number 5, quadrate. Everything's the same, including the vars business. So if I want to put this in a table, I want it to graph, press vars, move over one to y vars, enter, enter. Okay, look at this. So now it's y equals ax squared plus bx plus c. It's going to give you the a, going to give you the b, going to give you the c. If it doesn't say, round to the nearest hundredth. So let's see, for this data, what am I getting here? Y equals negative 0.0. Yes. Love technology. I love it. 0.05 x squared plus 6.68x minus 210.86. Now where is all this coming from? Up here. Here's A, rounded to the nearest hundredth. Here's B, rounded to the nearest hundredth. Here's C. And I have a new thing here. I don't see little r squared. I don't see little r. I see capital R squared. And what is it? R squared equals 0.989. I don't know if I'm rounding it right. Yeah, okay. It kind of means the same thing. Coefficient of, I want to say multiple determination. It's really the same thing as little r squared, but for a quadratic. So when I looked at what r squared was for my line, you remember what it was? I think it was like 0.83? Yeah, it was. This capital R squared, uppercase, that's the quadratic one. It means the same thing. It means about 98.9% of my points are really fitting a quadratic model. So for the same set of points, which is the better model, quadratic or linear? Quadratic. Why?
Because it's
Closer to 1, that 100% of the data fits. So sometimes, and usually, you're doing some research, you have plot data, you don't know what kind of fit it is. So you try them both, and you say, oh, okay, this one's better, this is more quadratic in nature, these numbers that I'm researching. Okay, make sense, not make sense? Questions? Questions on this? No? Good. Okay. So let's do an example here on the back. Okay, I'm on the back here. This is monthly sales of a new hair salon. Right? We opened in March, so that would be month 0. So that would make this April, May, right? And they're looking at their sales. Hopefully sales are going up. So find the best fitting quadratic model. How will I do that? Same thing as with linear. Stat, edit, whatever's in there, get rid of. I'm trying. You'll be able to do this faster than me. And then what goes in L1? 0, 1, 2, 3, 4, 5. And again, use your paper. My calculator's blocking it a little bit. Put in the data. Whoops, wrong thing. I wish this was. Okay, check your data. Garbage in, goes garbage out, so make sure these are correct. I'm moving a little closer because my eyes are watering. I think I got it right. So how do I find the best fitting quadratic model? That, how? Number 5 this time, quadrate. I'm going to hit bars, and I'm going to do y bars, enter, enter, because that puts all the data into the table for me in case I need it. So here we go. Y equals 0.12x squared plus 0.07x plus 5.6. Okay, so I'm just reading it off my calculator. Hopefully you're reading it off yours because this will make it go down. So substitute the a, the b, the c into ax squared plus bx plus c. Let's just see if I did that right. Okay. I think I matched. Make sense? Right? just plugging in A to B to C. All right, what's the estimate? What's the prediction? What do we think is going to happen in September? Well, what's my X value there? 6. So I'm going to use my model here. Now you could plug a 6 in here. That's perfectly fine. You can plug a 6 in and see what you get. Or I updated my table. So I can just do a second in a table. And wow, that's far away. I can scroll up, or I'm going to go to my table set button. And I'm just going to position my table a little bit closer to what I want. And then go in there. So let's see. At 6, I'm getting 10.45. Is that what you got?
I got 10.34.
Check your data. $10.45 thousand, because I think this is correct. Your data is correct. What you got? Okay. Now, how would I know if this is quadratic or linear? I mean, I said use quadratic, but maybe linear is better. How can I tell? I'm going to go back to where I ran it. My R squared was 0.9994. Oh my goodness, that's pretty good. Isn't it? Pretty close to 1. But I don't know, maybe R squared is even better. And what do I mean by R squared, small R squared, the linear one? So you just run a linear. That helps. Do a number 4, a linear regression on the same data. It's already in there. And my R squared is 0.935 something. So which one's better? The quadratic is closer to 1, so the quadratic is a better fit. Why? Because it's almost 100% of the data. Yes?
How did you get this 7?
How did I get 7? Well, let me run that again. I'm doing another quadratic. Because I had 0.069 and I rounded it up.
No, I mean in the L1 and L2.
How did I get this 7?
No, because you have like, I mean the 6. It was September.
Obviously,
It's not in there. So I put it, when I ran my quad reg, and I'll do that one more time, when I did the quad reg, you can just run it with nothing and you'll get the equation. But I wanted it to fill my table. Here's where you press bars, move over one to Y bars, enter, enter. See that Y one there? When you hit enter, it's filling up the table. So what you were thinking of, this wasn't my L1, L2. When I go in here, this is what, if X is 6, this is Y's value. Okay, so it's not the L1, L2, it's the actual table of data. So that's where I got that from. And this is the same thing we did with linear, right? It's really the same thing. What's different? You're pressing a different button. There's an A, B, and a C, and now you've got 2 different things to look at. So I want you to try this one on your own. I think you can probably do this one without me. Go ahead and see, we're rolling a marble down different lengths of slanted boards and seeing how long it takes. So time is always independent, right? So that's going to go here. So time is the X, and then this is your dependent variable, the length in centimeters. So go ahead and give this one a shot. When I did my stat edit, I put everything in, and then I did a quad reg. I did stat, calc, number 5, and then on my quad reg, I wanted to fill the table with data. So now you press bars, move over one to where it says Y bars, then you press enter for function Y1. See this here? It's putting it in your Y1 equals, whatever you get. Then hit enter. So you should have gotten this. To be at least agree on this part, and look at my R squared. Wow, that's pretty good. It's pretty close to 1 right there. And then I can go into my table, I can see the data. Now it says, on the graph, how long would it take for the marble to roll 15 centimeters? They're giving you a Y value. When does Y equals 15? So I'm looking over here. It's going to be a number between 5 and 6. Now those of you with the newer calculators, if you hit plus right now, if you have a newer calculator in your table, hit a plus. And it should say, let you make a delta right there. I don't think this one won't let me do it. So I'm going to go into my table set, and I'm going to change my table delta to count by halves instead of counting by ones, because then I can really see the 15 is happening at 5.5 seconds. Okay, that's using that. So when you know the Y, you have to find the X. The other one says, how long will it travel in 3 seconds? Well, here's 3 seconds. It'll go approximately 4.4 centimeters. So they give you the x, here's the y. The other question, they gave you y, find the x. What?
For 15, I got 113.1.
Does that make sense? Now remember, there may be two answers, because this is parabolic. So you may be getting it on the way down, but think about what you're doing. I'm rolling this little ball here on the floor here. It's probably this one. Probably this one. Yes.
Wait, how do you get diagnostic on?
Press the catalog button above the zero.
Oh.
Okay. Now the last question, how do we know that a quadratic model is better? Well, r squared, we can see it. Look at that, 0.999, right? It's off my little chart there. For the other one, just run it again with a linreg. Stat calc a linreg. Nothing fancy because I'm really just looking for the r squared. 0.92. So who's better? The quadratic is closer to 1. And that's why we're picking that one. And that's basically all there is to a quadratic regression. Are there questions? This is just like the linear, except we're just taking a little step